Hey guys, welcome back. It's Miss James again, and we're looking at Module 3 now. This is the first lesson, and we looked at this Friday, so you should have most of this filled out, but I just want to review it. It's this similar figures again, same shape, not necessarily the same size. We looked through each of the pairs of shapes and decided if they were similar or not. So pair A, we said were similar. They had the same shape, but they were different sizes. Pair B, not the same shape. One was a square and one's a rectangle. We know that for them to be similar, they would have to just be a bigger size square or a smaller size rectangle. Pair C, they were congruent. They were the exact same shape and size. Pair D, they were the same shape, just a different size, so those were congruent. And then here's the answers for E, F, G, and H. It should be similar for pair D, not congruent. So now let's look at scale factor. So you guys learned a little bit about scale factor in 7th grade. We're just going to review what we need to know with scale factor and introduce our new vocab term, which is a dilation. So dilation is a transformation. So we've already covered 3 transformations. If you recall, the other 3 transformations were reflections, translations, and rotations. Those were all basic rigid motions, which meant it preserved the length and measure. They created congruent figures. We're going to look at our 4th transformation. This one is not a basic rigid motion because this transformation enlarges or reduces the size of a figure. So it doesn't maintain the same shape and same size. It does maintain the same shape, just not the same size. Anytime you perform a dilation, you have to have a center and a scale factor. The center is just the point where everything is either reduced or enlarged from, and the scale factor tells us how much it is reduced or how much we enlarge the figure. We use the variable r to represent scale factor. Dilations create similar shapes, so that's how we get a similar figure. A similar shape is through a dilation. Okay, so similar shapes, as we said earlier, the same shape, just not necessarily the same size. It has been enlarged or reduced using a specific scale factor from a certain center. So the equation that we are going to use, so you want to make sure and have this in your notes, the equation that we're going to use for determining measures or the scale factor is this right here. It is the prime measurement, or our new one. We know that prime means the new one. So our prime measurement, or the new measurement, is equal to r, which is our scale factor, times the original measurement, or times the old measurement, as you might have heard it called quite a bit last year. So we want to make sure that you have this information, what a dilation is, what you need to dilate a figure, to know dilations create those similar shapes, and then this equation that we're going to keep using to answer the following questions. Okay, so problem 1, we're going to use this equation, plug in the information that we have, and answer the question for part A. So it gives us this, and it has OP in absolute value bars. What that means is the measurement of segment OP. So the measurement of line segment OP is 5 inches. Since I don't see a prime notation here at all, I can know that that means that is the original measurement. So we know that the original measurement is 5 inches. So if I use this right here, I know that the original would be 5 inches, so I know at the end I'm going to take it times 5 because that's my original measure. If this segment is dilated by a scale factor of 4, so our scale factor equals 4, so I look up here in my equation, scale factor is times the original measurement. We already have the original measurement, so I plug in 4 for my r. What is the length of segment OP prime? So now I know that one's the prime measurement. So I'm looking for this OP prime. So to find this, I just go through and I simplify what this says. P is going to be, or this prime, this new measurement, it's going to be 4 times 5, which is 20. So the length of segment OP prime is equal to 20 inches. We want to make sure and put our label there. Part B is going to be the exact same way. I'm going to give you a minute. I want you to try to do the exact same thing for Part B. So to solve part B, we set up the same thing. We know the original measurement, OP, is 5 inches, so we're going to take something times 5. It tells us that it's being dilated by a scale factor of 1/2, so I know R is being taken times the original. So I'm going to take 1/2 times 5. What is the length of the segment OP prime? I know that's the new measurement that it wants me to find. So my prime measurement, my new measurement, is 1/2 times 5, which I know half of 5 is 2.5. So I can say that the measurement of OP prime is equal to 2.5 inches when it has a scale factor of 1/2. All right, so I'm going to look at this problem right here. You see it has our line segments. I have my center O, I have point P and point P prime, point Q and point Q prime. So I know it's been dilated from the center O, and it just wants to know what we can determine about the scale factor. So we said in the beginning, scale factor can do two things. It can enlarge a figure or it can reduce the size of a figure. So since my P prime is out here, and I know that everything gets expanded from the center, if my point P was here, which is the original, and my new point was here, I know that my dilation was an enlargement. So I know it was an enlargement, and I can look at Q and Q prime and see that Q prime is also further away from my center, which means that it's an enlargement. And what we know about scale factor, what we're going to find out as we keep going through this, is that any scale factor that is greater than 1 is going to create an enlargement. So any number greater than 1, 1.5, 1.7, 2, 100, any number greater than 1 is going to create an enlargement of the original segment or the original figure. So you can go ahead and make the note. So this is the answer to this one. This was an enlargement. But we might just want to go ahead and make the note that a reduction, you can see that, a reduction is going to be where the scale factor is going to be less than 1. So any fraction that is proper is going to be a reduction. An enlargement, like I said, is anything greater than 1. So 3/2 reduces down into 1 1/2, which is greater than 1. So 1 1/2 or 3/2 is an enlargement. But if I have 2/3, that's a proper fraction. That's less than 1, so that would create a reduction. So if I can see that the prime or the new one is further away from the center, then I know that it is an enlargement. If it would be closer to the center, then it would have been reduced to the size of the original figure. So I want you guys to take a look at this shape. If you would sketch this in your notes, and I want you to figure out what you can determine about this dilation using the information that we just looked at. This is the P prime, this is P, this is Q prime, and this is Q. So give me all the information that you know based off of this drawing right here. You can pause and rewind back to the previous example if you need to look at that. So for the next part, numbers 2 and 3, it gives us an actual diagram. So it's very similar to 1A and B where they give us a scale factor, except this time we actually have to use our diagram to help us figure out the answer to number 2. So notice I have my equation here that I know I'm going to be using anytime we start talking about scale factor and measurements. And it says if the scale factor is R equals 3, what is the length of the segment OP prime? So as soon as I see that prime measurement, I know that it's asking me for that new measurement. So I know the new measurement is what we're trying to find, so I use that variable in for our new measurement, equals R, so we know R equals 3, times the original measurement. So if this wants to know OP prime is my new, then my original measurement would just be O to P, which I can see is 3 centimeters. So now I solve for N, and I know to find my new measurement, I take 3 times 3, which is 9. So now I have the answer to the measurement of OP prime, which is equal to 9 centimeters. We always want to make sure and label if they give us the unit to label with. Number 3, use that definition of dilation to show that our answer for number 2 is correct. We know it's correct because it is an enlargement or a reduction. In this case, the scale factor is 3. I can see it's further away, so I know that it is an enlargement. Using the previous examples of 2 and 3, where we worked out the measurement of OP prime, I would like for you to rewind if you need to go back to be able to answer problems 4 and 5. So 4, you're going to use that scale factor of 0.3 to find the length of OQ prime. And then for number 5, you're going to explain how you know that that's correct using our previous definition. Again, if you'd like to use the example that I did prior to this, that would be a great idea. Okay, for our next example, we have another diagram here. It has an additional line to the one that we've seen earlier. And we have parts A, B, and C. This time, part A says using the definition of dilations with lengths OB and OB prime. So OB is the original all the way here, OB prime right here. Determine the scale factor of the dilation. Now in the previous examples, we've always been given the scale factor. So now we have to determine the scale factor. We are still going to use this equation that we've been using the entire time. We're going to plug in the information that it gives us. So our prime, or our new measurement, would be the OB prime. So I look at my new measurement of OB prime and I see that that's equal to 5. I know that it needs to be equal to my scale factor. Now this is what we do not have, so that's why I'm going to leave that the variable r, times the original measurement. Now we do have the original measurement of O to B, which is 15 units. So now that I have the equation, I'm going to do the same thing I did previously and solve for the variable, but this time the variable is my r. Now r is being multiplied by 15. I know to solve an equation I do the inverse, which is divide both sides by 15. 15 divided by 15 is 1, so I have 1r. 5 divided by 15. If you divide them, you get 0.3 repeating, but we know with our scale factor we're going to leave it a fraction of a number, so we are going to reduce it to 1/3. So part A, I know that my scale factor for this drawing is 1/3, which makes sense. It is less than 1, which is a reduction, which is why all of our prime measurements, our new measurements, are closer to that center point. Part B, use the definition of dilation to determine OA prime. So now I have my scale factor. I'm looking for my new measurement. So part B we'll do here. I'm looking for my new measurement of OA prime. I can say that my scale factor is 1/3 and my original OA is 3. So I solve that for my new measurement, which is 1/3 times 3/1, or just 1 unit. So my new measurement, or my OA prime, is equal to 1 unit. And lastly, part C, right here, use the definition of dilation again to determine OC prime. So now I know I'm still looking for that new measurement. It is equal to my scale factor, or 1/3, times the original OC measurement, which I can see is 6 units. So when I simplify that, or I solve that for n, I take 1/3 times 6, or 1/3 times 6/1, and I know that that means that my new measurement for OC prime is equal to 2 units. All right, so now it's going to be your turn. We just did a problem very similar to this. I just did with the OP, A, and the C primes, and now I'm going to let you try that. It gives us the information that OP is 3 and OP prime is 9. So if you want to plug that in, you can. I draw this and you know OP prime is 9 centimeters. If you have that information, how could you use that to determine the scale factor? You should know by now that anytime we're talking about scale factor, we are going to use that equation where the new one, or the prime measurement, is equal to scale factor times the original. Using that information, I would like for you to A, determine the scale factor of this figure, and B, use the definition of dilation to find the measurement of OQ prime. So you're welcome to rewind and look at the previous example to help you find that. I'm sure you guys are going to do a great job with that. Mr. Gray and I are excited tomorrow to see what you have found, and any questions that you still may have. Make sure that you have your notes page with the definition, the equations, and all of the practice problems that you are supposed to try. Have a great night. We'll see you tomorrow.